Welcome back to the Explainer, students. Today, we're diving straight into Chapter 3.2, Binomial Expansion. Now, I know looking at a massive algebraic expression can feel totally intimidating, but trust me, we're going to turn those scary formulas into easy marks for your SM015 paper. Think of me as your personal Matriculation lecturer for the day, and I'm here to give you the exact strategies you need to score full marks in your PSPM. Let's get into it.
Okay, so let's do a quick little warm-up to set the stage here. Picture this. You're sitting right there in the exam hall. You flip the paper over, and boom, you're asked to expand a plus b all the way to the power of 20, manually. Take a deep breath. How are you going to handle that?
Because look, we all know how to expand an expression to the power of 2, right? We've done that since secondary school. A plus b squared is just a squared plus 2ab plus b squared, Senangja. But to the power of 20, we absolutely do not have the time to expand brackets one by one, term by term. That would literally be an exam nightmare. So we desperately need the ultimate shortcut.
So here's our masterclass roadmap for today. We'll hit Intro to Binomial Expansion, Pascal's Triangle and Factorials, the General Term Formula, Finding Specific Coefficients, Expanding Rational Powers, and finally, Approximating Valid Values.
All right, kicking things off with Part 1, Intro and Pascal's Triangle. So this beautiful little visual pattern here is Pascal's triangle, and it gives us our expansion coefficients. It's actually super simple to build. You just add the two numbers directly above to get the number below. So 1 plus 1 gets you 2, 1 plus 2 gets you 3, and so on. Now this method is absolutely perfect if you're only expanding up to power 3, 4, or maybe 5. But drawing a massive 20-row triangle in the exam hall, yeah, no way. Not practical at all.
Which brings us to Part 2, Factorials and NCR Notation.
Okay, let's dive into how we actually handle those bigger powers. We use something called factorial notation. Basically, if you see an exclamation mark next to a number, like n factorial, it just means you multiply that positive integer by every integer below it all the way down to 1. So 8 factorial, that's 8 times 7 times 6 down to 1. And we combine this with the NCR notation for our binomial coefficients. But here's the best part, the really great news. You do not have to calculate these manually. Just locate that NCR button on your scientific calculator and let it do all the heavy lifting for you.
And that brings us to this, the full binomial expansion formula for a plus b to the power of n. I know, it looks giant on screen, but please do not panic. Do not try to blindly memorize this whole thing. You just need to learn the pattern. Basically, as you move from term to term, the power of your first term, a, goes down, and the power of your second term, b, goes up. It starts at n and goes down to 0 for a, and from 0 up to n for b. It's like this perfect, predictable algebraic dance.
Moving on to Part 3, the general term formula.
Now this is where we build our ultimate exam shortcut. If a question asks for just the fifth term, you don't want to expand the whole thing, right? So we use the specific term formula, TR plus 1. It equals NCR multiplied by a to the power of n minus r multiplied by b to the power of r. This formula is literally your best friend for SM015 because it lets you jump straight to any specific term you need. Huge time saver.
Next up, Part 4, Finding Specific Coefficients.
Okay, here is your exact step-by-step strategy for one of the most famous exam questions, finding the term independent of x. Step 1, pull out your a, b, and n values. Step 2, plug them straight into that TR plus 1 formula we just talked about. Now, Step 3 is absolutely crucial. Independent of x strictly means the power of x is 0. So you collect all your x indices and equate that power to 0. Finally, Step 4, just solve for r. But hey, listen to me, one massive tip here. Always put a bracket around your negative signs in Step 2. Seriously, that is the #1 careless mistake I see that costs students their A grade.
All right, on to Part 5, Expanding Rational and Negative Powers. So we're entering final boss territory for this chapter now. What happens if our exponent, n, isn't a nice, friendly, positive whole number? What if n is -3, or maybe 1/3? Well, we need a completely new method. Why? Because our previous formula relies on factorials. And as you know, you can't exactly have a factorial of a fraction, right? So look at the comparison here.
On the left, we've got our familiar finite formula for positive integers. But on the right, check out the new formula for fractions or negative powers. This one creates a never-ending, infinite series. And you really need to look incredibly closely at the first term inside that bracket on the right. It literally must be a 1. If it's not a 1, you have to factorize your expression until it is. No exceptions.
Let's quickly break down the rules for this new formula. Like we just said, it has to be in the format of 1 plus ax to the power of n. But here is the major trap students fall into. They forget the validity condition. Because this is an infinite series, it's only mathematically true if the modulus of your ax term is strictly less than 1. So you must always solve and state your validity interval for these questions. Oh, and please don't forget to write your ellipsis. You know, those 3 little dots at the end, just to show the examiner you understand that this pattern continues forever.
And finally, part 6, approximating valid values.
Let's wrap this up by looking at how incredibly powerful this math actually is in the real world. By substituting a carefully chosen valid x value, like say 1 over 125, into an expansion like 1 plus 3x to the power of 1/3, we can calculate really complex roots entirely by hand. The math just unfolds so beautifully, allowing us to find something like the cube root of 2 without even needing a computer.
To put that into perspective, if you punch the cube root of 2 into your scientific calculator right now to check, you're going to see 1.25992. And our manual binomial expansion approximation, just using the first few terms, matches that exact calculator value to 5 decimal places. Honestly, that's just the crazy power of a mathematical series at work.
All right, students, there you have it. You are officially equipped with every single strategy you need to tackle binomial expansion. You've got the patterns, the validity rules, and those ultimate exam shortcuts. But before you close this explainer, grab your pen right now and try finding the coefficient of x to the power of 5 and 3 plus 2x to the power of 7 using that TR plus 1 formula. Test your memory. And as you do, just think about what we did in that last step. We used a simple sequence of fractions to tame infinity and calculate complex roots by hand. If a few terms of an expansion can give us the exact cube root of a number, what other secrets of the universe are just waiting to be expanded? Keep practicing, good luck with your PSPM revision, and I will catch you in the next explainer.